mighty pulverizer, turning rock into power. Ever wondered how a massive power plant burns something as solid as a chunk of coal? You can't just toss a big lump of rock into a fire and expect a steady, powerful burn. That's where the coal pulverizer, also known as a mill, comes in, and it's a truly amazing piece of machinery. Think of it as the world's most powerful coffee grinder. But instead of coffee beans, it's crushing tons of raw coal. Its job is to take large, coarse pieces of coal and grind them into a powder so incredibly fine that it can be blown into the boiler and burned almost like a gas. This isn't just for show. It's a matter of pure physics. By increasing the surface area of the coal a millionfold, the pulverizer ensures that the combustion is rapid, complete, and highly efficient. The faster and more fully the coal burns, the more heat is generated, which means more steam, more turbine spin, and ultimately, more electricity is produced from every single lump of coal that enters the plant. It's the essential first step that turns a raw fossil fuel into a controllable, explosive energy source. The inner workings of a coal pulverizer are a testament to heavy-duty engineering. Inside that enormous shell is a constant grinding battle. A typical mill uses heavy steel rollers or enormous grinding balls that press against a rotating table or bowl. As the coal feeds in, it gets caught between these grinding surfaces and is crushed into a powder. But the job isn't done there. A stream of hot air is injected into the mill, which serves two critical purposes. It dries any moisture from the coal, and it carries the finely ground powder upwards. A device called a classifier at the top of the mill acts as a quality control system, separating the superfine powder from any larger pieces. The fine powder is whisked away to the boiler burners, while the larger, unground particles are dropped back down to the grinding table for another pass. This continuous process ensures a consistent, high-quality fuel supply, preventing the boiler from receiving lumpy coal that would burn inefficiently or unevenly. Inside the pulverizer, a gritty job. When a coal pulverizer roars to life, it's a deafening beast. Its internal grinding a thunderous testament to its power. But when the plant shuts down for maintenance, that thunder gives way to an eerie silence. And that's the crew's cue to go inside. Climbing through a small manhole, you enter a dark, dusty, and strangely confined space, surrounded by the guts of a machine that weighs more than a freight train car. Your headlamp cuts through the thick coal dust, illuminating the true scale of the workhorse. The centerpiece is the massive grinding table, surrounded by monstrous, smooth steel rollers, each one heavy as a small car, all designed to crush rock with incredible force. The repair job isn't glamorous. It's a gritty, hands-on task of measuring wear. Crews use specialized gauges to check the surface of the rollers and the liner plates, looking for every millimeter of material that has been ground away by the relentless friction of pulverizing coal. Their mission is critical. If these parts get too worn, the mill can't produce the fine, consistent powder the boiler needs, leading to inefficient burns and a drop in power output. It's a tough, dirty job that only happens when the machine is at its quietest. But it's what ensures this giant can get back to its powerful, rumbling work of keeping the lights on. The unsung heroes of a power plant, grinding rolls. Ever wonder what turns a giant pile of coal into the fine dust needed to power a massive steam plant? It's not a magical process. It's the relentless work of a pulverizer. And at its heart are the grinding rolls. These aren't just any old rollers. They're the unsung heroes of the operation, tirelessly crushing and grinding raw coal into a powder as fine as talcum powder. Imagine a giant industrial-sized pestle and mortar, but instead of one big lump, it's a series of massive, heavy-duty rollers pressing down on a rotating table of coal. This intense pressure, we're talking tons of force, breaks down the coal's hard, rocky structure. The pulverized coal, or PC, is then blown into the boiler, where it ignites almost instantly, creating the heat that boils water into steam. It's a critical high-stress job. These grinding rolls have to withstand incredible abrasion and heat, which is why they're made from incredibly tough materials like specialized alloys. Without them, the entire power generation process would grind to a halt. They're a perfect example of a complex, heavy-duty component doing a simple but vital fuel so efficient it can keep our lights on and our homes warm.